In the module on if and else, we briefly had a look at a couple of relational operators. When I talk about relational operators, I'm talking about things like greater than and equal to. You've seen those already. And let's now have a look at those formally. Let's make sure that we know each and every one of the 6 relational operators. Firstly, we have equals. Now you might think, oh well, that's pretty straightforward, but well, it is and it isn't. Notice that this symbol, the syntax, if you like, for comparing two variables for equality is the double equals sign. Compare that with the single equals sign, which is used for assignment, assigning one value to another variable. Single equals means assignment. Double equals means comparison. The number of times these are confused in the language of C is just uncountable. Mostly because programmers come from programming in other languages where they use the single equals for comparison. So they do that out of habit. Now, the funny thing about it is that will actually work. The compiler will allow the single equals sign in the place of a double equals sign. It means something completely different. It still means assignment. It doesn't mean comparison. But the compiler will let you do it, so the code will compile fine, but when it runs, it will not run as expected. That's something to keep a watch out for. If you ever find a piece of code that's not working as expected, I mentioned before that one of the first things to look for is a semicolon on the end of an if statement. Another one of the first things to look for is a single equals where you're supposed to use a double equals. Okay. We've also got apostrophe equals. Now we use, when we see the word apostrophe, when we see the symbol apostrophe, we always think of the word not. So that we read apostrophe equals as not equals or does not equal. In other words, if x does not equal y, blah, 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 blah. Also we have is greater than. Now we've seen that before. That's a greater than sign. Straightforward, and the opposite of that is less than. We also have a greater than or equal to sign, which should be fairly self-explanatory. It's the combination of if it's greater than or if it's equal to. So if we say if x is greater than or equal to y, that will be true if x is greater than y or if x is equal to y. And the corresponding one if x is less than or equal to y. Okay, those are the 6. That's all there is. Let's now examine some coding samples of this. This won't take long because they are, as you've seen before, quite straightforward. Here is age4.c. We're just going to use this as our test bench for some of the relational operators. Most of it you've seen before, so I'll just scroll down and have a look at the bits that you might not have seen before. I've just rearranged this bit of code here, checking about what age people are. I use a less than or equal to sign, and I use a greater than or equal to sign. Okay, I think that's fairly straightforward. Now, however, there is something that I would like to demonstrate here in this piece of code, something that you might not have seen before. It's known in programming terms as the dangling else problem. The dangling else problem. We don't have a dangling else problem here, but I'll introduce one for you. See if you can see what I'm getting at. Oops, deleted one too many lines there. Okay. Now we potentially have a dangling else problem. It's this little else right here. The first if statement is if age is less than or equal to 19. The second if statement is if age is greater than or equal to 13. Which of those two if statements is the else attached to? That's the question. Well, you say, well, it's obviously attached to this if. Well, why do you say that? What if I rewrote the program like this? Just removed a bit of white space. And now I said, which if is the else attached to? Okay, now it's not so clear, is it? It looks like it could quite easily be attached to the very first if statement. and thus we have this dangling else. We have this else stuck out at the bottom of everything, and we don't know which if it's attached to. That's why it's known as the dangling else problem. Now this obviously compiles, and it will obviously run. So the compiler is going to make a decision. The question is, which decision does it make? And I'll just give you the answer because I can't expect you to know. The else is always attached to the closest if, the closest one. So if you read back up the page, the first if that you come to that could possibly be connected with that else is the one that it's connected to. I'll redo this slightly now, and you'll see a slightly different state of affairs. Okay, now we don't actually have a dangling else problem at all. Before, I told you that the else was going to be attached to the previous if statement, the closest if statement, which would have been, of course, if age is greater than or equal to 13. Now, I've just rewritten the code slightly by adding some curly brackets, and this time it is clearly attached to if age is greater than or equal to 19. And the reason is this. We go through this if statement, and we get to the end of this. Now, if we go on to the next line, the compiler would be expecting to see an else here. But there isn't one. Instead, it reaches a curly brackets, which means that's the end of that if. That if is over. If we reach curly bracket, close curly bracket, then we couldn't possibly have an else statement. So this else now can only possibly belong to the first if. So that is what you do if you need the else to be attached to the first if, when it was actually going to be attached to the second if you didn't put any brackets in at all. That's the solution. Okay, I'll just put things back the way they were. Okay, let's have a look at this line here. If age is less than or equal to 19, if age is greater than or equal to 13. Now obviously, if age fulfills both those two criteria, then the person must be a teenager. They're in the range 13 to 19 inclusive. Notice I use the word inclusive there because we're dealing with less than or equal to and greater than or equal to. So or equal to means inclusive, essentially. So, that's a pretty straightforward collection of if statements. But I'm wondering, is there possibly a way that you could say on one line, on one if statement, somehow, if age is between 13 and 19 inclusive? Is it possible to say that? I'll let you have a bit of a think about that, and we'll examine that in the next module. Okay, but we're not quite done with this module yet. We've still got another relational operator to have a look at. Let's have a look at not equal to. Let's read in somebody's name. We've all seen that before. Now, let's have a look at this line. If Struckump name Bruce not equal to 0, what could that possibly mean? Well, let's examine it bit by bit. Okay, and that's what we do if they're not equal to Bruce. Now, this bit of code here, the highlighted code, that is calling a function. And the function is called Struckump. And Struckump is short for string compare. String compare. So we read that as if string compare name Bruce. So what we're actually asking is for the function to compare the name that was entered with the word Bruce. So we need to test essentially if Bruce is if the name that they entered is equal to Bruce. So how does Struckump work? Well, Struckump will return a value of 0. It will return a value of 0. In other words, everything that you see highlighted will become equal to 0 if the name does equal to Bruce. So if name is equal to Bruce, you'll get a 0 back. You've got to be clear about that. Otherwise, you'll get some positive number or you'll get a negative number, depending on whether name is alphabetically before or after Bruce. So if name was Charlie, you would get a value greater than 0, and if name was, say, Alan, you would get a value less than 0. So all got to do with where it fits in the alphabet. But if it happens to be equal to Bruce, then Struckump will give you a value of 0. So what we're saying here is if that value that is returned by Struckump is not 0, notice that this is not equal to 0. In other words, if the name that the person entered was not Bruce. Does that make sense? Think about that if you don't get it. So if they did not enter the name Bruce, then we can simply say, well, you're not called Bruce, do you mind if I call you Bruce? Thank you, Monty Python. A couple of things are being demonstrated here. The first is the use of the new function, the new string compare function that you haven't seen before, strict. And the second is the use of the not equal to operator, just here. And thirdly, we're seeing that you can actually put an entire function call inside an if statement and compare it with something. When I say compare it to something, what I mean is I'm comparing the results of the function call to the value of 0. So, that's about it. We've had a look at greater than or equal to, less than or equal to, not equal to, and in previous chapters we also saw the equal to, the double equals, and we also saw a greater than sign. I think we even saw a less than. So, that pretty much wraps it up for